Hello everyone, this is Sir Abdur. In this video, you will be able to learn how to attempt question number 2, part B 4024, paper 2, variant 2, May June 2011. The shaded area represents a rectangular picture frame. The outer rectangle is 32 centimeter by 20 centimeter. This is the length 32 centimeter and 20. This is your outer rectangle. This is outer rectangle. The shaded area is the frame, and this is your inner rectangle. 26 by 14, the inner rectangle. Now, all measurements are given to the nearest centimeter. The nearest centimeter is the key to find error. This is the key to find error. So, in lesson number 1, I have explained how to find an absolute error for upper bound and or lower bound. So the nearest centimeter means it is nearest 1 centimeter. Nearest 1 centimeter. So your absolute error will be, or you can say error will be for all measurements 1 over 2, or you can say 0.5 centimeter. Now in part A, calculate the low part 1, part 1, calculate the lower bound of the perimeter of the outer rectangle. The length of the outer rectangle is 32 and the width is the outer rectangle is 20 centimeter. So perimeter, recall the idea about perimeter, the sum of all outer boundaries. Perimeter is the sum of all outer boundaries. So I'm going to start the solution. Perimeter is the sum of all outer boundaries. There are two lengths and two lengths here, which are both are 32, and the two width both are 20 centimeter. So we can write twice of length. This is length. This is your width plus twice of width. Now, since you have to find the lower bound perimeter, so the simple formula, first you have to write the simple formula: perimeter equal to twice of length plus twice of width. So this is simple formula, but you have to convert it into the lower bound of the perimeter formula. Recall the indirect approach for additions in the lesson number 2. I have uploaded for upper bound, lower bound. So perimeter of lower bound, perimeter, or you can say lower bound perimeter. Lower bound perimeter will be twice of lower bound length. Lower bound length plus twice of lower bound width. I have explained the Lesson number 2, that if you are going to add you are or the two quantities and to find the lower bound of all values must be the lower bound. You have to take all lower bound values. So the lower bound length twice is as it is lower bound length. Length is 32 centimeter for the outer rectangle and the error is 0.5. Lower bound means you have to subtract 32 by minus 0.5 and then plus twice of lower bound width. Lower bound width of outer rectangle, because you have to find the lower bound perimeter of the outer rectangle. So this is 20 is the width here. So 20 minus 0.5 the error. You can use calculator because it is paper 2 question. 32 twice of 32 minus 0.5 is 31.5 plus twice of 20 minus 0.5 is 2 multiplied by 19.5. You can use calculator and enter all the values directly. So twice of 31.5 is 63 and twice of 19.5 will be 39. So 63 plus 39 will be 102. Don't forget to write answer in the answer space. This is 102 centimeter lower bound perimeter of outer rectangle. Lower bound perimeter of outer rectangle. Now move on. Part 2. In the part 2, calculate the upper bound of the area of the frame. Recall the shape. Your shape was, this is your outer rectangle and this is your the inner rectangle and the shaded region was your frame. This is your frame and the length of the outer rectangle was 32 into 20. This was the length of the outer rectangle and the width of the outer rectangle was 20. The length of the inner rectangle was 26 and the width is 24. 26 of the length for inner rectangle and 14 is the width. Let's check again. 26 by 14, 20 into 30. Okay. Calculate the upper bound of the area of the frame. So, upper bound of the area of the frame, you have to formula to find simple formula. First, you have to write the simple formula. This is indirect approach because formula is I'm using the formula. So, area of the frame, area of the frame is area of outer rectangle minus area of inner rectangle. Now, this is a formula, but recall indirect approach. Indirect approach, when there is a subtraction case, when there is a subtraction case, if you are going to find the upper bound, and in the for subtraction, indirect process for subtraction cases, the first value must be upper bound and the second value must be changed lower bound. So I'm going to write area of the if the area of the frame will be area of frame is required upper bound. So area of outer rectangle must be upper bound minus area of the inner rectangle must be lower bound. Okay, so the upper bound for upper bound area of rectangle, for upper bound area of outer rectangle, you should know the upper bound length of the outer rectangle and the upper bound width of the outer rectangle. So it will be 32.5 because the error was, recall the error, was 1 over 2 or 0.5 centimeter. So it is length into width, upper bound length of the outer rectangle multiplied by the upper bound width of the outer rectangle, which is 20.5 minus the length of the inner rectangle, but you have to take the lower bound, so it will be 25.5 times the width of the inner rectangle, but you have to take the lower bound of the inner rectangle, which is 14 point, sorry, you have to subtract 14. So you have to subtract 0.5 from 14, it will be 13.5. 13.5. Now use calculator. By using calculator, you can calculate 32.5 times 20.5. This will be 666.25 minus 25.5 times 13.5. Use calculator. This paper 2 question. It will be 344.25. So your answer, when you subtract, your answer will be 322. The significant figure, it is the area of frame, area of upper bound area of frame. The upper bound area of frame. This is the final answer. But don't forget to write answer in the answer space. This is the answer space here, 322 centimeter square. Hope you have understood how to use indirect approach of variation in this question. So if you feel in understanding any topic, any maths topic, do let me know in comments. I will make video on your request. So stay connected, like, subscribe, share, and press bell icon for more videos. Thank you very much.